Okay, we're doing a review sheet for the test. These were the first few up at the top. So you can pause it to look at it. Now we're on power property. How do I start power property of logs? Log base b. Yep. And how do I expand that out? Yep. So my exponent comes down in front. Okay, moving on to properties of equality of exponentials and of logs. So this would have been 6.6. Who remembers the power property of equality of exponentials? How do I write the property of equality of exponentials? So what is an exponential? Let's start with that.
When you make it from the number into a log.
That would be the first one. So that'd be like transferring it from an exponential to a log. Let's just start with an exponential. So this is what an exponential looks like, b to the x, right?
Okay.
Yeah? Okay, let's start with b to the x. We have base b to the power of x equals the same thing, but with a different power. I can do an if and only if and write this like what? Yep, x equals y. Set the exponents equal to each other. Yeah. Now we're going to do the same thing kind of with logs though now. So I'm going to take my log base b of x equals log base b of y. Still an if and only if. My log base b's are the same. So what can I set equal to each other? Yep, x and y. So the arguments. Now for both of these, what do I need for both of them to be able? Yes, need same basis. Now this one, I have a whole lot of stars. Why do you think I have stars? Yes, it's very important. What do you have to remember when we do these with the logs? If we're trying to solve a log equation. What, Piscovi? What do I have to check for? Yes. Yeah, so check for extraneous. Extraneous solutions. What makes it extraneous? Yes. Also with logs, it's something special. Close. If it makes the argument negative. So can't. So this right here, the x is our argument, or the y. These are arguments. Argument. Can't have a negative argument. In a log. What is it going to say on my calculator if I do put a log of a negative number? Say it again. Yes, it's going to say domain error. In the argument of a log. I should have made that box a whole lot bigger. What about my change of base formula? So we start with my log base b of m. What does that equal? Yeah, so log base a of m. What is a? Yep, a is the new base. And what do we normally use for the new base? Yes, because log base 10 is what, Kyle? What is log base 10? look up on your sheet. Second one from the top. Yes, common log. So, thank you, Angel. So we either use log or what else? What else is a nice log, RJ? What else do we use when we use change of base formula? We don't just have to use log base 10. We can also use what other log? Yeah, ln. So natural log. Either one is fine. So I'm going to finish writing this. On the denominator is log base A of B. And you don't have to use log. You can also use ln.
So what's A?
A is our new base. So in common log, the new base is 10. And in ln, it's E. But we don't write those. Yeah. Any questions on the first page? No? Okay. Okay. When we're given equations, when we're trying to solve, which property should I look out for first? When I'm solving an equation, let's say, I'm just going to write down below. Let's say I have my challenge problem up there that we did. Log base 2 of x plus log base 2 of x plus 3 equals 2. What do I always have to check for first? Yes, because what can we do if we have the same base? Yes. Something. Yes, we can use one of our properties. So we check if we can use these first. Check to see if we can use these first. Check to see if you can use these first. You should look at your properties first. See if you can combine any logs, if you're using logs. You don't have to write down the problem. It was just an example to get us thinking. Yeah. We already did it on the board yesterday. Same problem. And then you can move on to the properties of equalities and see if those apply to this problem. Check. Second. And you might need to change it into a log or change it into an exponential. What's up, Glenn? Okay. So when we were solving this, what did we do first? Yep. So we used the product property first. So we had log base 2 of what? X plus 3 equals 2. Okay, do I have logs on both sides? Do I have exponentials with the same bases on both sides? No. So I can't use equality. So I gotta think, do I have to change it to an exponential? Or can I change it to a log? Will it help us? Yep. So what did we change it to? So you want to change it to an exponential function? Yeah? Okay, how do I change that to an exponential function? So start with my base. So my base is 2. Good. So whatever my output is becomes our exponent. And then whatever our argument is right here, we put on the outside. Goes there. So we have x plus 3. Yeah. The first one on the top will help you do that. Okay. And then we solved this yesterday. And then we check for what type of solutions. Yep. Okay, those were all of our logs. I'm scooching down to the next page for our formulas. Okay, what is the general formula for an exponential? Yes. And then sometimes we also have an a value outside, which is like our initial amount. Yeah? Mm-hmm. What do you say? A so let's keep B with our base. Let's just keep that the same, because it's going to help us when we switch into a log. Okay, exponential growth and decay formula. Who knows it? Starts with A of t. 1 plus 1? 1 plus, 1 plus r. I didn't like that. Yes, to the t. 1 plus r to the t. So is that growth or is that decay? Growth. How do I write my, so this is growth. How do I write my decay? Yep. 1 minus r to the t. What does a represent? Yep, a is our initial value. What is r, Kennedy? Rate. And how should we write that? Yep, as a decimal. What is t? Time. Yep. Time. Okay, continuous compounded formula. Still starting with a of t equals what? What? Yes, PE to the RT. Okay, what does P represent since it's new? Yep, initial value or principal. Yes. Okay. Okay. A of t for continuous, not continuous, we're not doing that one. Compounded interest. It's a, yeah. To the, what was it? Yes, perfect. So this is a very close relation to the one up above, down below. But what is n? In what? In t. Yeah, so the number of compounded events in t. So if I was talking about years, what might n be and why? What do we normally do? If I say the interest is compounded quarterly, what's n? Just 4. So the rate is written as a decimal. This isn't written as a decimal. Yes. Just 4. Because this, yeah, you can chop up a year into 4 quarters. That would be not quarterly. Quarterly is 4. Yeah. What about monthly? What about weekly? 52. I would write these down. If you, I'm not sure. Yeah.
So, and it's just like,
Annually is like, how many years are in a year? 1.
so it's just 1.
Yeah, then we would use this formula right here.
12, so it's just that.
Yeah, because I keep doing it within a year. So T is a year, most of the times. I'm probably going to give you T as years. and then you have to see how many of these events are in the year.
Okay.
Yeah.
So T is the amount of years.
Yeah, it's going to be specified what T is, but T is going to be years.
Okay.
Yeah. So if I said daily, what would it be, Kennedy? 365. 365. Keep with that. Okay. Look at the next two. Okay, the next three you guys are going to fill out on your own in your own time. We have talked about leap year. I don't like leap year. We don't do leap year. Yeah. Well, that's up to them. Okay, I want you to look at graphing and exponential. What is my asymptote? How do I get it? I was wrong with that. So if I have an exponential, give me an exponential function. Landon, give me an exponential function. Yep. I give you a hint. It starts with y equals. Exponential. So x should be in the... So what's an exponential? Y equals b to the x, right? Okay, so give me a value for b. Anybody? 12? Okay, 12 to the x. Then we have to have a k. There's a k for regular transformations. Go with the x or outside the x? Okay, give me a number, Naomi. Okay, plus 4. Can I erase on this? I don't think I can. Okay, I'll wait that in a second. Okay, 12x plus, what was it? 4. Okay, we get our asymptote by doing x equals whatever k is. So our asymptote would be x equals 4. Okay, if I had an x-axis and a y-axis, we don't have to graph this, but what does an exponential function normally look like? Draw it with your hands. Draw it with your hands. This is my y, this is my x. Draw it with your hands. Everyone try it. Well, now, yeah, I'm doing your axis. Now draw on your axis. I know this is weird. So this is my axis. Where is it normally? What quadrants is it normally in? Okay, this is 1. What else? 2. Do we know what other quadrants? 3 and 4. Hey, we're gonna do this next week. We know what quadrants. So it normally looks something like this, right? Yes. No. It's still algebra, I promise you. Yes. Okay, so this is what an exponential function roughly looks like. With a horizontal asymptote. Which is, for this parent function, it's right here. So this is kind of like y equals b to the x. Okay, what does a log function normally look like? What quadrants? Yeah, this one? This one? Oh, I'm sorry, I'm not.
I just can't see them out.
No, that's fair. Are we talking about this one or this one?
We're talking about vertical, but can we put the y equals 12? Like, can we have an equation?
Yeah. I will definitely do that. You want to give me one? Y equals, we're talking about logs now. So give me any log function you want. Yeah. So let's start with log. Mark.
Oh, okay.
What base do you want?
2.
2? Okay. Keep going.
10.
I need a function. So put my x in there.
2.
So x, let's do x plus 10. Minus 2. So RJ, how would this look on a graph, roughly? What quadrants? Right here.
1 and 2.
So that's exponential.
1 and 4.
Yeah. So I have my line of reflection. So it looks roughly like that. That's my log. Let's sketch it. So Kenny, h is what in this problem?
It's 10.
Yep. So we have negative 10. Negative 10. So we can set the argument equal to 0 to get that. So x equals, x minus 10 equals x. So x equals negative 10. That's how we get it. Okay. So it roughly looks like that, with this being our asymptote. Any questions on any of these? I'm not going to go through how to graph them because you're going to do that on your team test. No? Okay, we're going into groups now.
Really?
Yeah, because everyone's talking, so you guys obviously have it already and don't have any questions. Naomi? You're Ronaldo. I know, because I didn't know really who was a 10th grader or not. I don't... Julia's not even here. Okay, get into your groups, and then I might shift them around. I might switch groups around. So, get into groups, and then I'm probably going to switch you.
Yeah, I don't know what they are.